Hi again, this is Dr. Mahmood, and in this video, I'll be talking about histogram. Histogram is another tool that we use it for quality assurance, and through the histogram, we can find if the process, uh, uh, we could find the process variation, whether we have a spread or we have the values clustered around the mean. So the histogram is similar to frequency diagram, and the most notable difference between the two that a histogram, the data are grouped into cells. So if you look into the histogram on the right side here, you will see that uh, values, uh, these values, they're divided into groups. So from 40 to 50, that would be maybe two. From 50 to 60, that would be three. 60 to 70, that would be 5. 70 to 80 would be around 12 or 13. So this is the only difference between the frequency diagram and the histogram, that the data in the histogram is divided into categories, groups. Each cell contains a range of values. The height of each bar shows how many fall into each range. Something that we need to consider, that histogram, we use it with the continuous and variable data such as height and weight, grades, something like this. But if we say um, there could be something different if we're talking about categories, data, nominal data we call it, or ordinal, we have to use a bar chart. So the histogram would not work in this case. And normal data would be such as colors, such as black, white. If you have if you're surveying a customer and you say, what is your favorite color to see on a car? So I'm assuming that you're going to do a QFD and you want to see what is the most desirable color for your customer. You say, what would be the most favorite color for you? And you say, blue, black, red, etc. So in this case, histogram would not work for you. We could use the frequency diagram. But if we have a weight, height, uh, that would be something that measurable, that we could measure it, inches, uh, pounds. These are could be the best way to use the histogram for it. So let's take an example. If you want to measure the length of the lumber wood that you have in a warehouse, and these, you know that the heights for these pieces of woods will vary from 100 inches to 340 inches. So you decide to put that into groups of 50, and you said, okay, I want to start from 50, and the 50 is here, in from 50 to one, starting from 100. So 100 plus 50. So the first category would be 100 to 150, 150 to 200, 200 to 100, 250, 300, 300 to 350. And then you start measuring these pieces of wood, and you found that the 100 to just below the 150 inches, the 150 to just below the 200 inches. So some people, they would say, okay, what if I have 150 um, length? That would be a perfect question, but usually we have it from 100 to 149.9, for example. So if it's 150, will be to the next category, and so on. So a piece that is 260. So if we measure the piece that has a 260 inches, that would be fits into this category right here. 1, 2, 3, onto the fourth category between 250 and 300. So that would be the place to put that. And the result, as you see here in this chart, and you could see, for example, there are 30 pieces right here between from 150 to just below the 200. When we say just below to the 200 inches tall, that means 199.9. But to simplify things and to make it fit on the chart, we say from 150 to 200, and then from 200 to 250. All right, now we're going into a more practical thing and how we could create a histogram. In order to create a histogram, you need to follow these steps. Step number one, collect the data construct a tally sheet. And this is where we said you could maybe do a tally sheet or frequency sheet, whatever you want to call it, and then something that you measure the occurrences, how when it's happening. And then the second step would be calculate the range, and the range could be found by calculating the maximum minus the minimum, and then determine the number of class of intervals. We need to find out how many intervals we have. As you see, these groups we called intervals, so we need to find out how many groups we're making here. And then, and this is the best way to do that, to find out the square root of n. So whatever the square root of n, rounded to the higher number. For a fewer than 100 pieces, this is the rule of thumb. If it's fewer than 100 pieces of data, then use between 4 to 9. If it's between 100 to 500 pieces of data, use from 7 to 17 cells. If it's more than 500 or more, then use 15 to 20 category or interval. Create the cells by determining the cells intervals and boundaries. So what we need to do, we need to find out the boundaries, which means the beginning and the ending of each group. So in the previous example, we said from 100 to 150. So, and we created how many categories here? I'm going to go back just a second to show you exactly. So we have created 1, 2, 3, 4, 5, and this is just based on whatever you want. And then the boundaries would be from 100 to 150, then from 150 to 200. So number one is, as you say, collect the data, find the maximum minus the minimum, which is the range, determine the number of intervals, how many categories how many groups you will have, and then you could use the root of n or any of these rules that that I've listed here on these slides. And then we need, in step number 4, is to create the cell, which is basically you need to find the intervals and the boundaries for each cell, the start of the group and the end of the group, and that could be the width, could be the range divided by the number of intervals. That's the easiest. Or you could divide the standard deviation by 3 if that's what you want to do. And the nice thing, there are so many ways for doing it. There's no one way for it. There are a lot of ways. So I'm trying to simplify it as much as I can here. So I'm going to show you an example in just a second on how to apply this. And then label the axis, and then post the values. And the last step would be interpretate the histogram. So let's take a look into creating a histogram, and we'll come back to the analyzing of the histogram. And I'm going to share with you my Excel here. So I'm going to stop share this and share here this one here. So what I have here, we have the number of customers on the left side, the left column, and I have the wait time for each customer. So we're interested in knowing if we're doing a good job or not. Do we have a variation in serving customers or not? So we went there and we observed the time wait for 20 customers. So the first customer was 43.1 seconds. The second customer 35.6. The third customer 37.6 in seconds. So all these times in seconds. So what we need to do, we need to follow the steps as I shared with you in the slides in order to create the histogram. So what I did here, first of all, there's a function in Excel where you go to insert and you go to histogram and you select this one. You will have this type of diagram. However, this is not accurate, and as you see, this is could be difficult to interpret and hard to read. So it does not make a lot of sense to me. So I, in this case, the first thing what I want you to do is try this. If you see that the chart looks nice and you are able to interpret it, that's fine. You can do that. But for me, I thought this is not a good way to interpret the chart. So I want to use the steps that I shared with you on in the slides to create my own histogram. So the first thing I did in first step, we collected the data. The second thing that you want to do is do the range. Find the range. The range would be calculated by maximum minus the minimum. And there's a function in Excel called max. So equal max, and I selected these data minus the minimum, and I selected the same data back, and that would find me the maximum value in this set of data, subtract from the minimum value of the set of data. The next is to calculate the number of intervals, how many categories I will need to create. And I said, okay, well, the square root of n. So I did say 20. We have the n, the number of sets here, the number of datas, the sample size is 20 to the power of 0.5, which is the square root. There's another function of finding the square root as well. If you do equals square root, yeah, here's the square root sqrt, and find the 20. You put the number 20, and that will give you the same thing. But what I think square root is to the power of 0.5, and this is what I'm used to it. So I said 20 to the power of 0.5, which is the square root of n. That will give me 4.47. And what I wanted to do, I wanted to um, round it to the next higher number. So 4.4, the next higher number would be 5. So I know that there are 5 categories, 5 groups. And now for the width, we divided the range by the interval, which is 5. And that would give you 4.76, again rounded to the bigger number, so the width is 5. Next, what you want to do, look into this data here, and what I did, I ranged it from A to Z, sorted from A to Z. That will give me the smaller number here and the bigger number down here. So I looked into the small number to be 30.3. So I thought, okay, well, 30 would be the starting point. Add to that 5, which is the width. So the first category would be 30 to 35, and then 35 to 40, 40 to 45, 45 to 50, 50 to 55. So that's create 1, 2, 3, 4, 5 categories. And then I start counting the number between the first category, in the first category from 30 to 35. That would be 3 numbers right here. So as you see, 1, 2, 3. And now next category, 35 to 40. So 35 to 40, that would be these 1, 2, 3, 4 numbers. And now next, from 40 to 45, that would be from 40 to 45, that would be these numbers, 1, 2, 3, 4, 5, 6, 7. So I did record it 7 here. And then from 45 to 50, and that would be 1, 2, 3, 4. So I listed down 4. And then from 50 to 55, that would be 20. Just to confirm that we have 20 values in here, I did add these together, and that gave me 20, just to verify that I did not miss any of these values. So now let's go and create the chart. So I'm going to delete this for you for now. So what I did, I selected the data here, and I went here, insert, and I selected the bar chart, and I selected a regular bar chart here. But as you see, this looks like more as a bar chart, which because there are some gaps in between each category. So what I want to do, I want to remove these gaps, and I want it to look like a histogram. So I want to go here to the right click, format data series, and the first thing you will see is the gap width. And for the gap width, make it a 0 and close the option, and that would be the histogram. And here's what you have to do, is change the title to histogram for customers wait time. All right. How this is important for me? That's gonna give me as a quality manager, there are a lot of things that you could learn from here. So you could learn that, first of all, that the data is normal. And why this is normal? Because you are able to fit the bell curve on the top of it. And if you divide the data, it will look symmetrical, which means that the right side is equal to the left side of the diagram. So what I want also to know, I will, from this histogram, will give me the range of the values that I have. So as you see, this range from 30 to 55. And it is important to see if my specification as a quality, my specification fits within these 30 to 55. If not, I don't have any processing control. I have to work on my process to make it in control and bring it to the specification that I have. So there are a lot of things that you could learn from the histogram. The most important thing, the histogram will help you to see if there are variation in the process, if there are some variation in the process or not. So last step, as I mentioned, what you need to do is to interpret the histogram, and this is based on the shape of the data, how the shape look like, the spread of the data, and the characteristic used in these characteristics, the shape, location, and spread, we use it to describe the distribution. And the shape will look like symmetry, squeeness, and kurtosis. In symmetrical distribution, the two halves, the mirror, basically, if you divide we said there is a bell curve on the top of the data, and if you divide it to the two halves are mirror image of each other, the two halves correspond in size, shape, and arrangement. Squeed, if we said this is a squeed, they could be squeed to the right or to the left, which means the majority, if the majority of the data are grouped on the right or left, see where the most of the data are clustered, grouped. Is it on the right or on the left? And kurtosis would be the peakness. How long is the peakness? And your goal is to have a high peak on your data, because the longer peak is, the less variation in your process. And the location, you could interpret the histogram based on the location. Where is the distribution in relation to the target? So you put the targets, the specification limit, and upper specification limits and lower specification limits, and you put the data in there, and then you see, is it centered, is it shifted to the right, shifted to the left, and you could measure the central tendency using the mean, the mode, and the median. And the spread is also another way to describe the data analysis. See how the distance between the highest and the lowest value, that would be the dispersion, the range, and the standard deviation. We could use that. So the location would be measured by the mean, the mode, or the median. The spread would be using the range or the standard deviation, which is basically the spread of the data, the distance between the highest and the lowest values. Here are some charts that you could use. So this is, for example, I'm going to focus on one of these. This is where the normal, this is the target, and see, this is a normal data. It's distributed. If you divide it into two halves, you will see the data on the right is almost equal to the data on the left. And this is process too high, so you have to adjust it. And this is where we talk about the specification. Our target should be here, and our process should look like this. But if we see that the process is shifted to the right, that means we're having too high process or too low process in this case. This is the negatively squeed, and this is the positively squeed. This is where the data is clustered to the left side, and here the data is grouped or clustered on the right side. And there says the kurtosis, where the peakness of the data. So if you look into this, just by looking into these two, you'll see that the standard deviation here is the standard deviation is lower than the standard deviation, which means the spread of the data is it's not spread as much as this one here. So there are a lot of information you can get from the histogram just by looking into the histogram and compare it to the target and see where the data whether centered or not. All right, now just a few things before I finish this video. I want to just, we did talk about it, the central tendency. If we need to measure the central tendency, that would be the mean. And the mean, which is basically the average, it's could be calculated by adding all the values together and then divide the sum by the total number of values. And I'm sure some of you familiar with it. It's an easy, simple thing. You add all the values together and you divide it by the number of values. And for the median, you will see the median is the value that divides an ordered series. So you have to order you have to sort the series from higher to lower, and then the value that divides these ordered series into two halves, into two equal numbers of values, that would be the median. That would be the median. And the mode would be is the most frequently occurring number in a group of values. In a group of values, this is the mode. It would be the most frequently number, and these are the measures that we use it to measure the central tendency. And for the measuring the dispersion would be the range and the standard deviation. The range would be the difference between the highest value in a series and the lowest value in the same series. So maximum minus the minimum. And the standard deviation shows the dispersion as well, and it could be calculated by, and this is the sigma. Basically, we find the sigma if it's for the population, we use this one. If it's for a sample, we use this equation. Uh, so the square root of the summation of x minus the average to the power of 2 divided by n, or the only difference whether divided by n or divided by n minus 1. Either way would be used to calculate the standard deviation. And now that will take us to another topic, another interesting topic, to find the probabilities and the areas under the normal curve. And that's should be in a different video. And so I thank you so much for watching me, and I'll see you in another video.